Okay, we are back, and I think I may have to shut down my browser memory issues. Okay, there you go. Okay, we were here on this slide, and we had completed the discussion on the state diagrams. And now we're going to look at a complete Python program which implements this state diagram. All right, and there we go. In Python and also in any other language, we had to break this. We'll have to create an object. It's useful to build an object. Actually, this is not the object. I'm going to this one here. So let's look at this slide first, or maybe just briefly, and then go back to the first slide. Okay. So it'll be a great idea to define a class for token. Okay, because token itself has got at least two pieces of information built into it, right? Beyond that, actual systems will have additional information, but the token, the string itself, okay, that's one of the values which you need to store, like the name of the identifier or the integer literal what number it is. Okay. Also, the token type. Okay, so that is. If you remember, we mentioned that tokens are nothing but named constants. Okay, so you'll have a named constant. So the actual constant 1, 2, 3, 4, 5. Okay, token number 1, token number 2, and so on. So those two values are important to store. And if you have to store other information like the line number and the offset from the beginning of the line where this token appears, which is typically stored. Okay, those two integers can also be stored here inside this. Okay. But when we build this, we will not store those two pieces of information. It's easy to add that. Okay. Okay. So now let's look at the whole program. It's made up of 3 files, and actually at the end of it, we will actually go to the terminal, and you can see that there is a file called tokentypes.py here. Okay, and that's what I'm showing there on the slide. Also, the token.py, which is the class encapsulating the information for token. Okay. And that's the next slide. And after that, we have a Lexical.py, which contains the actual program for the state diagram. Okay, and then we have a main program to test. So actually, there are 4 programs here, or 4 Python files, 4 different files. Okay, token types, token, Lexer, and Lexer test. Okay, so these 4 put together constitutes the Python program, which implements the state diagram we just discussed. Okay. So let's look at the token types. Okay, this is pretty standard way to code it in Python. Okay, so if you have to build a lexical analyzer for a different language, you still have the same code, except that the token names which you have chosen will be different. That's all. Okay, so this file is pretty straightforward. We use the built-in enumerated type within Python. Okay, you should look it up if you're not very familiar with this. There is this is a package. Enum is a package, and capital NUM, enum is that object. Okay, and that allows you to name. So these are not strings, but these are these are identifiers, the L-parent, L-parent. So this is how this enum will work. Okay, and with each of the names for the we have the token number. Okay, so this is pretty standard. Okay, so enumerate all the. It doesn't matter in which order you do this. Okay, so L parent, R parent, or L parent can come at the end. It doesn't matter. Okay, but this last one probably should be at the end. Also, its number is off. Okay, it's not very critical. Okay, so order is not important. So we have L parent, R parent, and we have the add, which is the plus symbol. Okay, and then the minus symbol, and the multiply and the divide. Okay, and then we have the ID for the identifier, the name of the variable. Okay, and int for the. So it's a little bit. If you go back to the diagram, here we call it ident, IDENT. Okay, and here we call it int underscore lit. Okay, so I'm changing the name, simplifying it slightly. Instead of ident, I'm just calling it ID. Okay, and instead of int underscore lit, I'm calling it int. Okay, so that's here. Okay, int and ID and int. Okay, this essentially this not is the same as the ident and int underscore lit. Okay, I don't like long names. That's why I chose these names. Okay, although for this one we could have called it LPAR, LPAR, okay, RPAR. and made it even shorter. That's fine. Okay, so you list all the tokens you have, including the EOF, which is the end of file token. Okay, that's necessary. Okay, because that token will be reached when you reach the end of the whole input. Okay, and these numbers are starting at 0, I guess. EOF was typically 0, but after that you go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there are 8 types of real tokens, and there's one token called EOF, end of file. Okay, that's all. So you create a file like this. So if your tokens are different, you just have different name value pairs here. Okay, helper and one. So this enum class makes this particular name get associated with this integer. Okay, that's what it does. So whenever in the future in the program you say lparen, okay, without quotes. This is actually now like a keyword now. Okay, if you just use lparen, then its value will be the 1. Okay, rparen its value will be 2, and so on. So instead of saying token 1, 2, 3, we can just call them this name. So that's just a convenience for readability, but otherwise these are just integers. Okay. All right. So that's the first file, token types.py. The next is the token.py. This is pretty standard, and actually this can be, I think, except for the string method, the rest of the code can be borrowed for any other. Okay. Of course, if you're storing besides the token and the value, you're storing the line number and so on, then you would need to modify that. Okay, but it's pretty straightforward. So if you're not very familiar with object-oriented Python, okay, you'll see it takes a little bit to get used to it. Okay, but I can explain give you a quick lesson on object-oriented Python here. Okay, in less than 5 minutes or 3 minutes or whatever. Okay. It looks pretty awkward and very different than Java. Okay, and that's why it's a little confusing to get used to object-oriented Python. Okay, but anyway, the way we define a class is we say class and then give the name of the class. Okay, and then a colon. Okay, as usual, colon ends the line like that. You see, and then after that you define all the methods. Okay. You don't define instance variables. Okay, so that's interesting, very interesting. So that's one difference. So already off the bat, there's one difference between Java classes and Python classes. In Java classes, you have to, after the class line is done, you have to define all the instance variables, correct? And then the methods. But here, the instance variables are implicitly declared, and I'll show you how. Okay. You're not allowed to define them here. Okay. All right. The init. This is the constructor. Okay. So this is a special name. Okay. This is how underscore underscore. These are 2 underscores, and init, and then underscore underscore. Okay. So that's how you name special. You'll actually see there's another special named method. Okay. So these are standard names which are used for any class. Okay. For a constructor, underscore underscore init underscore underscore would be the constructor method. Okay, and underscore underscore str underscore underscore would be the toString method of Java. Okay, so this is the toString method of Java. Okay, and this is the constructor, default constructor of Java. Okay, I'm sure you can have other types of constructors, but we are going to just go with the standard. Okay, default. All right, so you define the constructor first. Okay. Def underscore underscore init underscore underscore, and then you provide the parameters and the colon. Okay. Now in the parameters, you will notice in all of the 4 methods here, these are the actual real parameters, but there's an extra parameter called self sitting in all of them. Okay. Self. That looks like a little bit of a pain to keep typing this in every method. Okay, but it's required. It's a quirk of Python. Okay, we can't help it. Okay. This method is necessary if you want to make this an instance method. Okay, I guess you can leave it out, then it becomes a class method. Okay, but we will not be getting deeper into object-oriented Python at this point. So when you have an instance method, you know the difference between instance method and class method, I hope. Okay, anyway, if it's an instance method, we have to put the self. Okay, because an instance method will be called on an object, correct? And that object will be assigned to the self variable here. Okay, and this is a keyword, so you have to say self, or maybe not. I don't know. I guess it is the keyword. Yeah, self. Okay, I think you have to look up. I believe you can use other words here, but everybody uses self there. Okay, you can look it up. Okay, so that's required if it's an instance method. Okay, and these are the parameters which come into the constructor. So this is the initial values for the variables. Okay, but the actual variable is defined here: self dot underscore t. Okay, and self dot underscore c. So what you put here in the constructor, any variable you get which gets assigned a value, that variable becomes the instance variable for this class. Okay, so it's an implicit definition of an instance variable. Okay, and it's not necessary to begin these names with underscore. Okay, it's not necessary. You can just say self dot t and self dot c. Okay, but I chose to do underscore underscore. And there is a lot of Python programmers do this because many times you have instance variables and you also have other local variables. And if you don't sort of syntactically differentiate between the two, which is what we do in Java, right? We normally just use any variable name. Here also we could do that. I don't think it's a big deal. Okay, but there are many Python programmers who will actually deliberately name instance variables beginning with underscore. Okay. I've chosen to do that here, okay? And actually, it's a good practice for your code to become robust and error-free, okay? Or at least not introduce unnecessary errors, okay? Anyway, not a big deal. Self dot underscore t is assigned tok, which is the value here. It's nothing but indicating that we have an instance variable called underscore t, and we are assigning it the value coming into this parameter, okay? And when you call it, you will actually construct without the self. Okay, you'll obviously construct the object. You'll probably use a class name and then provide the token and the value. Okay, those two. All right, those two values you'll provide, and then they get assigned to these two instance variables. Okay, we'll see how token is constructed because we're going to construct tokens in this program. Okay, so this is the standard constructor. Okay. And then there are two getters. Okay, I didn't do setters. Okay, in this, if you want, you can do setters too. Okay, but I don't because I set it in the constructor itself, and after that I don't change it. You see, in this particular program, the objects are pretty straightforward. Token, they get you create a particular token object, and then it gets fixed. It doesn't get modified, and so on. You may have to consult it, look into it. That's why we have the two gets. Okay, get token and get value. Okay. Get token, it takes no parameter, but there's a default parameter self which is necessary in Python, right? So when you call it, you'll just say get token left right parenthesis, okay? But you'll call it on an object. You'll say t dot get token, right? So that t becomes the self, okay? The object on which the method is called. And this just returns self dot underscore t. Okay, again, this is how you refer to the instance variable, self dot and then the name of the variable. Whole bunch of typing. See, this is the one thing you have to get used to. Okay, maybe Python should have done a little better on this, but it's too late to change Python right now. Okay, but that's I'm sure there is some reasons on why it was chosen like that. Okay, so these are the two getters. Okay. And there's an underscore str underscore method. Okay, this one basically, if you call this, you get a string version of that. Okay, string, so that you want to print, right? So I'm going to print tokens at the end of the whole program. I'm going to read something and print the tokens. So this will be used to print a token. Okay, you'll actually convert the token into, or I guess by default it gets converted using this particular method. Okay. Anyway, what I do here is I look at the self dot, again, there'll be object on which this method is called, self dot underscore t. Okay, I look at that. And the t itself has, let's say, self dot underscore t dot value. Okay, yeah. This dot value is the enumerated value. Okay, so if you remember here we discussed this enumerated. So enumerated type, the token value would be this enumerated type. Okay, one of these. Okay, we will see how we assign it, and it has an ID and a value. Okay, so when we say dot value, we are referring to this one here. Okay, got it? Yeah, this is a little confusing, but self dot underscore t is a token. Okay. Token, and we haven't seen how this TOK gets assigned. We will see that, okay, in the main program. But take it for now that when you say this token dot value, then you actually get that value, which is the 1 or the 2 or the 3. Remember, we gave integer values for each token. That value you get here, okay? And then, this is how you access the tokens.id, token types.id. So that's the name given to the token. And then when you say dot value, you'll get the number 1 or whatever, okay? 1, 2, 3, that value, okay? So this is how you access the value on both sides, on the actual value of the token here, and also on the ID's tokens value. So here, basically, we're checking whether this particular token is the ID token or not, okay? And if it is, this is how you check, is inside this method. Outside the method, we'll see how we check it, okay? But inside the method, this is how you'll check whether the object on which the method is called is the ID token or not, okay? And if it is, then I create a string which is made up of a left angle bracket plus is a concatenation, self dot underscore t. So this token itself, okay? So you'll probably get there's a default to string on the enumerated type, okay? We'll see what we get when we print it, okay? And then a colon, and then the actual value, because self dot underscore c is the string value which you get here, okay? Which will be, let's say, x1, x2, or whatever for an identifier, okay? So you'll actually get two things here. You'll probably get an ID, and then you'll get the actual value for the ID, which is x1, x2, x3 here, and then a square angle bracket there. So this is the string I will see when I print an ID token, okay? And similarly for the int token, I'll just print the value. I don't need to say int, okay? I'll just print the value, okay? If you want, we could have done that self dot underscore t here. Then you'll see the int and then the actual integer, okay? Not a big deal, just a bit little different. I did that, okay? Yeah. All right. Otherwise, I will just return the token itself dot underscore t, because in that case it's a single character, right? Single character token, because these are the only two non-single tag. So we'll see how this. We'll just return the self dot underscore t, okay? So that one will come in the form of a string, I guess, okay? Yeah, this one here. Okay, we'll see when we run the program what we get out of that. But anyway, very simplistic class called token, which will encapsulate two values, the token value and the actual value of the token, okay? Got it? Actual value of the token, okay? That's important, okay? Which makes more sense in the ID and the int cases, which will be the number or the actual variable name or the number, okay? All right, so we have this second class here, token.py. Then we look at the lexer.py, which is the actual main program, okay? This is, goes into two slides here, okay? But it's, this is the one which actually implements the state diagram going from one state to another state, okay? Not exactly, okay, but you'll see a lot of similarities between this code and that, okay? And actually there's a very nice systematic way you write this code. Okay, so let's look at this class. So now let's look at a couple of the imports, okay? Or three. Import sys, okay? So the reason we do the sys is probably down somewhere here, let's see, or maybe that's not necessary, I don't know. Sometimes I include, yeah, we don't use sys here. And I don't think we use sys here. Yeah, that's probably a carryover from something else, okay? Yeah, I think I probably carried this over from I wrote the Lexer test and then first and then I did this or something. Anyway, you can actually comment this out. We'll actually see in the program, or let me go to my terminal just to see lexer.py, okay? I do have that, yeah, but we'll comment it out and see whether it's really needed, okay? But the other two are needed, right? From token types import star and from token import star. So we are going to import all the token types, the enumerated types, and also the token class, which has the two getters and then the constructor and then the string method, okay? And we're going to the class. We'll build this as a class, and this is also always important to build a class because Lexer object is what we have to create, and this object will have a lex method, which is which is in the second slide here. Lex method, which will be exposed. Okay, so this tokenized method probably is an internal method which is not exposed. So I could have Yeah, I guess that's fine. This is also exposed, but the user of this class will not be using it, okay, calling it. Okay, this is an internal method. If you want, you can call that. Okay, all right. So let's see how we do this. Always remember that we're going to get this is the input, or something like this is the input. Okay, the sum plus parenthesis sum plus 47 parenthesis slash total. Okay, that's the input we have. Okay, on which we are trying to tokenize. Okay, so we have a class Lexer. Okay, and we have a constructor here. Okay, let's see what the constructor is. It takes S as input. Okay, the constructor requires a string as input. Okay, and this is the string which contains this this whole thing here. Okay, got it? So this S will be that string. Okay, in the main program we'll see that. Okay, and all I do is okay. What I do here is I have an instance variable called underscore tokens. Okay, and it's a list variable. Okay, list. It will have a list as its value. Okay, and what type of list? It'll be a list of token objects. Got it? So in a sense, what the tokenize method here would do is it'll actually read the whole string, begin to end, all the way from the left parenthesis all the way to the L there. Okay, it'll read the whole thing and tokenize it, and each token it will store it inside this underscore token. All right. So when the tokenize completes, it'll return a list of tokens. So in memory, in this list structure, we'll store the tokens left to right. So in this case, you can see that there'll be 1, 2, 3, 4, 5, 6, 7. There are 7 tokens, and then the EOF token, the end of file token, 8. So there'll be 8 tokens here, and this self dot underscore tokens will be the instance variable. Underscore tokens will be the variable which contains the list of 8 tokens. Okay, for that example. All right, so this is all there is. Although this makes a call to the tokenize method here, which we'll have to study. Assuming that that returns a list of tokens, so that will be initialized there. Let's quickly look at the lex method, and then we'll come to this, okay? Because lex method is the one which, oh, by the way, in the previous one, we also stored index equals 0, underscore index equals 0, okay? So these two go together, the index and the tokens, the underscore index and underscore tokens. Underscore index is the index into this underscore tokens list, okay? Got it? And this last method is important because if you recall, we said that the parser will call the Lexer object for one token at a time. Okay, and it's the responsibility of the Lexer object to have this method built in, and this is the method we are talking about. Lex, we call it. Okay, sometimes it's called next token, next underscore token. Okay, but in this case, we chose to call it lex. Okay. And it doesn't take any parameter except for the self parameter, which is the Lexer object itself. Okay, and let's see what it does. Okay, it starts with t equals none. Now none is a special value in Python, which is like a null value. Okay, all right, and then what this does is that if it checks, so because it has to get the next token, the index tells you what the next token is. Okay, and it checks if self dot underscore index is less than the length of the self dot underscore tokens. That means we are still within the array of the tokens, and also we'll assume the EOF token is the last token, and also because we're checking for less than, okay, so the index is actually pointing to less than the length, okay, is pointing to, oh, I guess it can point to even the EOF, okay, because if it is equal to the length, then it'll be pointing beyond the list, right? So yeah, got it. So it is pointing to one of the valid tokens. Okay, it's important to do this if check here. Otherwise, you'll be in trouble, right? You may go out of bounds. Anyway, if it is equal, less than length of that, that means we are looking at a valid token. So t is self dot underscore tokens bracket self dot underscore index. So it'll extract the token and put it into t, and also it'll advance self dot index by 1. Okay, why? Next time lex is called, you get the next token. That's why. Okay. And then here, we just return t, okay? But just so that we can debug this program, I printed it here, okay? Got it? You can see how I'm printing it. Next token is, and then t.get token, right? T is a token object, and there's a get token, method, okay? And let's go back here to this. Yeah, here's the get token method, okay, which gives you the token itself, okay. And so here you'll actually see the token, like a L paren, R paren, that kind of printout you'll see here, okay. And oh, actually no, it'll be the str. Remember the str method we wrote there? So we convert this to string, okay, using the toString method, the underscore underscore str method. And whatever that method will produce, that's what will be printed here, okay. And then comma, next lexeme is, so I want to print both the token and the lexeme, and the lexeme will be the t.get value, right, because that's the actual value of the token, okay. So this print is just for our debug purposes, but normally you will comment this out when you complete this lex, when the parser is going to use it, okay. All right, so now all we have to do is look at this tokenize method, which will actually read the whole string and break it into this thing. Okay, so it begins with result equals empty, because that's what we want to create, right? A result is a list of tokens, and starts at I equals 0, because this string is nothing but a list of characters, right? So that's what a Python string is. It's nothing but a list of characters. So you want to start looking at it character by character, starting at I equals 0, okay? And also the while loop will, while I is less than len of s, we had to keep doing this, okay? And let's look at what happens outside that, okay? I guess these are the two statements which happen outside that while loop, okay? And once we reach the end, what we do is we append the EOF token. Remember, that is the token we have to append to that result, okay? That append, and this is how we construct. Okay, here's the first time we are seeing how to construct a token, okay? This is the constructor method, init method inside the token.py, okay? Token, that's how you give construct. We don't say new. That's one difference. Another difference. There's a whole bunch of differences, but that's another difference between Java and Python. We don't say new token. We just say token, okay? And in parentheses, we provide the two values which are required. One is the tok, T-O-K, remember? So token types.eof, that will be the top enumerated type. And then a value which and a file doesn't have, so you can actually it actually has a token value which is a 0, but that's different than the actual value which the token has, and here we just say -1, okay. Yeah, the actual value for an integer will be the number, like 45 or 64 or whatever the value is, right? So that's this one here, okay. So outside the while loop, we just append the end of file token to the result and return result, okay. So that's what happens outside the while loop. But now inside the while loop, we are examining each character, right? So single character at a time. So which is very much like the automata, which is looking at one character at a time, okay? So let's see what is this. So what we do is we put that character into C, okay, into the variable C. C is assigned S sub I, okay? And then we check for what it is, okay? So now instead of the lookup function, remember we had the lookup function, which single characters. I probably should have done that, okay, because you can see that there's a whole 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 21, okay. There are 21 lines of code which I could have really moved to another helper method, okay, right? And that is the point of the lookup, okay? So this is really the lookup, but it has been expanded out, okay? So pardon me, I probably should have done that, but that's okay. Or if you want, you can refactor this code and put that into the lookup function, okay? So you can actually have a lookup function here as well, okay? Helper, which actually encapsulates, and maybe that is a terrific idea, because then I could have seen tokenize all in one page. Or at least the while loop all in one page, if not the tokenize, but certainly the while loop. Yeah, even the tokenize, because the tokenize has got only 4 lines extra beyond the while loop, 2 before and 2 after, right? So we might have seen the whole tokenize in one page, okay? My bad. Anyway, that's fine. So this is the lookup. If C equals left parenthesis, then do this. Else, if it C is right parenthesis, do this, and plus, minus, times, divide. Or even the white space. You can see even the white space. If it's a white space character, these are the 4 characters for white space standard, okay? Then do this, okay? So this whole thing, you can quickly see. If you look at one of them, the rest, actually the white space is simple. All you do is I equals I plus 1 and continue the loop, okay? So skip that, okay? That's all, okay? but all the others are similar. So I'll just explain one of them, and then you can look at we can skip the rest, right? So if it's the left parenthesis, then we know that we have seen the left L parent token. Okay, so we create a token object, token, and then we provide the two parameters, the talk parameter, which is the token types to the L parent, and the value is the left parenthesis itself. Okay, so now you can see the value is a little different. See, the value is the left parenthesis, but the value of this token is I guess 0, right? Because it's enumerated type value. Okay, and this token has a token value itself, which is the LPAREN, which is the enumerated type here. Okay, so hopefully that's clear to you. Okay, so we create a token object which corresponds to the L parent and append it to the result. Okay, because the result must, and then we do I equals I plus 1 so that we can, and then continue the loop. Okay. Yeah, I guess we don't need the continue here. Okay, we can just leave it out because after this LF it goes back. Okay, yeah, or we should have put continue after each one of these guys. Okay, so I think the simplest is to remove this continue. Okay, anyway, so that's what happens on the single characters. Okay, pretty straightforward, right? So let's look at the is digit next. Okay, is digit. Yeah, I'm glad it all fit within this in these 5 lines. Okay, so let's look at the is digit rather than the is letter. Okay, so let's look at the is digit. Is digit actually is a Python function. Okay, a function method on a character. Okay, it'll tell you true or false if the character is a digit or not. Okay, so that's the one of those two options, right? If it's a letter, do something. If it's a digit, do something. So that's the check here. So what we do is we start another pointer j because we want to go down the S, okay, go beyond the first digit and find the last digit, right? So that's why we use another pointer. So I is frozen at the beginning, the first digit. Okay, I is pointing to the C, okay, and then J starts at I, obviously at that point, and then while J is less than len of S and S sub J is digit, okay. So as long as you keep seeing a digit, so this while loop is that self loop in the diagram, okay. You can see that how each of the code corresponds to the pieces of the diagram. Okay, so obviously we want to keep doing this only if we are within the string, and also as long as it's a digit, we say j equals j plus 1. So we keep advancing j until we find a non-digit or until we end up beyond the string. Okay, and when we come out of this, we would have I and j would be the two indices which will encapsulate the number or the integer which we are trying to extract. Okay, so you can see that in the result.append token types is int, and the value is s, the substring starting at I and ending at 1 before j. Okay, and that's standard in Python, like in Java, is that the second index is 1 beyond. Okay, and j is 1 beyond the last digit, right? Because that's we have just gone past the digit, all the digits in the while loop, and then j is pointing to the character after the digit. Okay, so s bracket I colon j will be the substring which will be the token type. Okay, notice that we don't convert it to int or float or whatever, so this is still a string, but it contains the number. Okay, that's it. So this will append that to the result, and then oh, this is important because you want to point I to that so that when we go back to the while loop, we are not processing the same number again. Okay, so you have to go beyond, and j is the right place to go because j is 1 beyond the number. Okay, got it. And the last case is left is for the alpha. Okay, and there's of course an error case too, but alpha is very similar to the previous one. There's a dot is alpha method. Okay, in Python, which will check both for uppercase and lowercase. That's good. The 52 cases it checks. Okay, and then the j equals I, and a result.append token types with ID s I j and I equals j, exactly same, and j equals j plus 1. The only difference is that the continuation s sub j, as long as s sub j is dot is a l for alpha and num alnum. Okay, al num. So that's luckily there is another method which checks for alphanumeric or digit. Okay, that's terrific. Python is very good. I'm not sure if this such a thing is available in, maybe it is in Java. Okay, but it's so compact. You can see the code. Python coding is so. This will continue as long as it's a digit or an integer, digit or a letter. Okay, so 62 cases it covers. Okay, and then the code looks the same. And else here means that the character you're seeing is something which we should not be seeing, right? Because, for example, let's say we had in this example, let's say a comma. Okay, comma is not allowed in this. Okay, in this particular regular expression or arithmetic expression, there's no comma. Okay, right? So if you see a comma in the input, it's an unexpected character encountered. Okay, error, and that's what you do. And you actually, oh, here is the sys. I did use a sys. Okay, sys.exit. So I exit this whole program. So import sys is necessary for that. Okay. That's it. So we have seen this whole program. Okay, I guess it's 35 minutes. So next time I will show a run of this program in the next video, and also we'll go to the next topic, which will be the run. We have seen the main program, or maybe not. So we'll see the main program and the run, and then we'll go to the next topic in the next video. Okay, so let's stop here.